In today's rapidly evolving digital landscape, the convergence of ethical hacking and generative AI has emerged as a powerful force in countering cybersecurity threats. As malicious hackers adapt and exploit advanced technologies, the need for innovative defenses becomes paramount. This course explores the cutting-edge domain of generative AI and reconnaissance techniques. I'll explore reconnaissance techniques leveraging AI's potential, and I'll demonstrate both passive and active reconnaissance techniques. I'll explore the challenges and solutions associated with reconnaissance and generative AI, and consider methods used to protect against reconnaissance. Finally, I'll explore how ethical hackers can use the information obtained during reconnaissance. This video explores reconnaissance techniques and details the differences between active and passive reconnaissance. The digital world is truly ubiquitous, delivering countless services and products to billions of people worldwide every day. Behind the scenes, it is often a battleground where the security, reliability, and resilience of systems are regularly tested by individuals and groups. This thought may evoke negative connotations, but not all activities are harmful. Ethical hacking is a proactive approach whose goal is to identify and rectify system vulnerabilities before malicious hackers can exploit them. A critical phase of the ethical hacking process is reconnaissance. Hackers gather relevant information about the target during reconnaissance. Let's define reconnaissance in ethical hacking and then explore the reconnaissance phase of the ethical hacking process by focusing on the two main types of reconnaissance, active and passive reconnaissance. I will typically refer to reconnaissance simply as recon. Okay, so recon is the first phase in the ethical hacking lifecycle, and it provides crucial insights about the target system, helping ethical hackers understand its intricacies and vulnerabilities. The information gathered during this phase forms the bedrock for all subsequent stages, influencing strategy, threat modeling, and vulnerability exploitation for the rest of the ethical hacking lifecycle. There are two main types of recon: active recon, which involves direct interaction with the target system, and passive recon, where information is gathered without directly interacting with the target system. Okay, first let's explore active recon. So again, active recon involves direct interaction with the target system. It's a method of probing, usually through pings, port scans, or other methods, to gather information about the system, its vulnerabilities, and potential entry points. Despite its efficiency in obtaining real-time data, this approach is more intrusive and hence more likely to be detected by intrusion detection systems. A popular technique within active recon is port scanning, employed using tools like Nmap. This process helps identify open ports and services running on the target system. For example, if a port linked to a database service is open, an ethical hacker could further exploit this potential vulnerability, considering it as an entry point. Okay, now passive recon. In contrast to active recon, passive recon involves gathering information without directly interacting with the target system. This stealthy method capitalizes on publicly available information and is less likely to be detected given its non-intrusive nature. A common passive recon technique is a whois lookup. Whois database stores information about domain names, including the registrant's contact details and the domain's creation and expiration dates. This information can be valuable in understanding the target's infrastructure. Similarly, DNS interrogation is another passive technique that uncovers information about the domain name system servers associated with the target domain. It can reveal critical details about a system's network infrastructure and potential vulnerabilities. So now let's consider active versus passive recon. The key difference between active and passive recon lies in their approach to information gathering. Active recon, as its name suggests, is a more direct and aggressive strategy. On the other hand, passive recon is a more covert method, leveraging publicly available information. Active recon involves actively probing the target system, while effective risks detection. Passive recon is a more inconspicuous approach and has a lower risk of detection. Active recon benefits include obtaining accurate, real-time data, which can provide more direct routes to system vulnerabilities. Passive recon may not provide as much detail or real-time data as active recon, and the data obtained can be outdated, requiring ethical hackers to verify its relevance and accuracy. Both types have their purpose in the overall ethical hacking lifecycle. In practice, ethical hackers often combine both techniques, using passive recon to gather preliminary information and active recon for more direct and detailed insights. Overall, reconnaissance is a pivotal stage in ethical hacking, providing the foundation for identifying and rectifying system vulnerabilities and setting the stage for the ethical hacking strategy. Both active and passive recon techniques have their pros and cons, and the choice between them depends on the specific context, objectives, and the risk tolerance of the ethical hacker. By leveraging these techniques effectively, ethical hackers play a key role in safeguarding digital systems from potential threats, contributing to a more secure, reliable, and resilient system. This video explores prompt engineering techniques for information gathering. The convergence of artificial intelligence and cybersecurity, particularly ethical hacking, has opened up a wealth of opportunities for enhancing security infrastructure. A technique at the forefront is prompt engineering, a method of constructing effective inquiries to generate specific responses from AI models. This video explores prompt engineering techniques using generative AI like OpenAI's GPT-4 and how these techniques can aid information gathering in ethical hacking. Okay, so first, prompt engineering. So in the context of ethical hacking, again, prompt engineering involves designing queries to instruct an AI model to provide specific information or execute particular tasks. The power of generative AI models like GPT-4 lies in their ability to understand and generate human-like text, which can be leveraged to simulate cyber attack scenarios, plan defense strategies, or gather information about potential vulnerabilities. By creating clear and precise prompts, ethical hackers can instruct AI models to assist in various tasks, such as generating phishing emails for penetration testing, providing insights on the latest hacking techniques, or simulating a cyber attacker's possible responses to different system configurations. Several techniques exist for crafting effective prompts. Common techniques include defining the output format, providing context or examples, and asking the AI to think step by step or debate pros and cons. First, consider designing output format. This involves specifying the type of response desired. For example, a list, summary, detailed analysis, or a specific number of suggestions. Another common technique is providing context or examples. Offering additional context or examples within a prompt can guide the AI model towards the kind of answer expected, which can be helpful in generating more accurate and detailed responses, and thinking in steps or debating. By prompting the AI to think step by step, ethical hackers can gain more comprehensive insights into a problem. Similarly, by asking the AI to debate pros and cons, hackers can stimulate the model to explore different perspectives on a cybersecurity issue. All right, now let's examine how these techniques can be used in the context of ethical hacking. First, we'll consider simulating attack scenarios. Ethical hackers could prompt the AI to generate a plausible attack scenario based on a specific vulnerability. For example, if a system vulnerability is related to SQL injection, an ethical hacker might use this prompt. Given that a website is vulnerable to SQL injection, outline a step-by-step process a hacker might use to exploit this vulnerability. Okay, another use case involves generating phishing emails. So, to test the robustness of an organization's phishing detection mechanisms, an ethical hacker may ask the AI to draft a phishing email. The prompt may appear like this. Compose an email that appears to be from a trusted bank, asking the recipient to verify their login details. Remember, this is for an ethical hacking exercise. And another use case, learn about hacking techniques. So ethical hackers can use the AI to stay updated regarding the latest hacking techniques. An example prompt might be, provide a summary of the latest trends in ethical hacking and defenses from 2023 to 2025. Okay, and another use case, simulating cyber attacker responses. An ethical hacker could use the AI to predict how a cyber attacker may respond to different defense strategies. For instance, we could specify if an organization strengthens its firewall configurations, how might an attacker respond? Debate the pros and cons of possible strategies. In these use case examples, we can get a sense of the value of prompt engineering. And while prompt engineering with AI opens up significant possibilities for ethical hacking, it's essential to underline that the use of these techniques should always adhere to ethical guidelines. The purpose of ethical hacking is to identify and fix vulnerabilities, not to exploit them for malicious intent. Therefore, AI-powered prompt engineering should be used responsibly, ensuring privacy, confidentiality, and consent are observed and respected at all times. This video explores different methods and tools used for reconnaissance. In the process of ethical hacking, the reconnaissance or recon phase plays a crucial role. Recon is the first step that involves gathering preliminary data or intelligence on the target. The information gathered in this phase can help identify potential vulnerabilities, thereby enabling the hacker to formulate an effective attack strategy. Generative AI has the potential to bring groundbreaking improvements to this process, further enhancing the effectiveness of ethical hacking. Let's explore some of the methods and tools used in the recon phase, with a focus on generative AI's role in ethical hacking. Okay, so traditionally, reconnaissance can be performed actively, that's with direct interaction with the target, or passively, with no direct communication. The goal is to gather as much useful information as possible without altering the target. Traditional methods include DNS lookup. DNS lookup is a technique used to identify IP addresses associated with the domain. Tools like NSLookup and DIG can provide a wealth of information such as mail servers, IP addresses, and DNS servers related to a domain. Then there's WhoIsLookup. WhoIs is a query and response protocol that is used for querying databases that store the registered user or assignees of an internet resource, such as a domain name or an IP address. The WhoIsLookup can reveal information about the domain's owner, their contact details, the domain's creation and expiration dates, and more. Then there's network scanning. Network scanning involves identifying active hosts, that's computers and servers, on a network, their opened ports, and running services, along with the details of these services. Tools such as Nmap are commonly used for network scanning. Then there's Google dorking. Google dorking uses advanced Google search techniques to find specific information on Google's index. This can include errors that reveal sensitive information, files of a certain type, pages containing specific phrases, and much more. Generative AI, with its ability to mimic human intelligence, learn from previous data, and generate new data, brings transformative possibilities to the reconnaissance phase of ethical hacking. These techniques include social media mining with AI, AI-driven web scraping, machine learning for network analysis, and AI for phishing detection. Okay, so first let's explore social media mining with AI. Natural language processing can be used to scan and analyze social media profiles, blogs, and forums to extract valuable data. It can identify patterns, sentiments, and trends that may reveal critical information about an organization or individual. AI-driven web scraping involves extracting data from websites. When combined with AI, it can be used to interpret the data and reveal patterns that a human investigator may miss. And of course, AI can process vast amounts of information much faster than humans and more accurately as well. So it's a very potent tool in the reconnaissance phase. Okay, next, machine learning for network analysis. AI and machine learning algorithms can be used to analyze network data and identify patterns, relationships in that network data, and recognize anomalies. This type of analysis can provide insights into potential vulnerabilities, including complex vulnerabilities that may otherwise be missed. This is how ethical hackers can identify critical areas of focus for further investigation. And AI for phishing detection. AI can be used to detect phishing attempts. Traditionally, detecting phishing attempts involved rule-based methods, and while effective to some degree, these methods struggle to keep up with the increasing complexity and velocity of modern phishing attacks. But AI, powered by machine learning algorithms, can analyze and learn from previous phishing attempts to enhance future detection. As we look forward, the integration of generative AI into the ethical hacking process is rather inevitable. With AI's ability to learn, adapt, and generate information, it has tremendous potential to enhance reconnaissance efforts. At the same time, however, it's important to realize that there are privacy and ethical use considerations that must maintain top priority. As with any technology, generative AI can be exploited for harmful purposes. Therefore, we must strike a balance between leveraging AI's capabilities for ethical hacking and ensuring that we do not infringe on privacy rights or cross ethical boundaries. This video explores the benefits that generative AI provides to the reconnaissance phase in the ethical hacking process. Generative AI is an incredibly effective tool. Ethical hacking is an essential process for protecting information and bolstering the defenses of systems and networks. Integrating generative AI provides many benefits to the ethical hacking process, and in this video, we'll explore the benefits of using AI in the reconnaissance phase. Recall that reconnaissance is the crucial initial phase in the ethical hacking process. It involves gathering data and information about the target system, working to understand its structure, mapping possible entry points for further investigation. The quality of reconnaissance significantly impacts the efficiency and efficacy of the subsequent steps in the ethical hacking process because it lays the foundation for future exploration and testing. Generative AI holds immense potential in enhancing the reconnaissance process in ethical hacking, in part because generative AI is capable of creating new data that resembles its training data. Generative AI is trained using a large number of cybersecurity scenarios, and therefore can predict potential vulnerabilities in a system, thereby helping to optimize the reconnaissance phase. Generative AI in the reconnaissance phase of ethical hacking provides an array of benefits, including efficiency. Generative AI automates information gathering, expediting the reconnaissance process. This allows ethical hackers to focus on strategy development and faster threat response. Another benefit is comprehensiveness. Generative AI, trained on diverse data, identifies a wide range of vulnerabilities, eliminating human oversights. This provides a complete set of potential weak points for ethical hackers to address. Its predictive capability is also a benefit. By predicting future vulnerabilities based on existing patterns, generative AI enables proactive cybersecurity. This foresight allows for preemptive actions, preventing potential breaches before they occur. Generative AI provides a benefit of dynamic adaptability. Generative AI adapts to emerging cybersecurity threats, offering an agile defense. This continual learning ensures that reconnaissance processes remain up to date with the evolving threat landscape. In-depth analysis. Generative AI provides a detailed analysis of system vulnerabilities by processing vast data volumes. This deep analysis allows for the creation of more robust and effective cybersecurity solutions. And resource optimization. Automating a significant portion of the reconnaissance phase with generative AI frees human resources to tackle complex security challenges. This results in more efficient resource allocation and improved productivity in the ethical hacking process. Let's explore some real-world examples. Okay, so example 1, vulnerability prediction in network systems. Consider the network system of a financial institution with an extensive digital footprint. A generative AI model trained on various network structures and historical cybersecurity events can be deployed to perform reconnaissance on this system. By analyzing the network's structure and examining its interdependencies, the AI can predict possible vulnerabilities and suggest potential attack vectors, thereby enabling ethical hackers to focus their efforts on these points. This proactive approach not only optimizes resource allocation, but also significantly increases the system's defense against potential cyber attacks. Example 2. Social engineering scenarios. In the case of social engineering attacks, where hackers exploit human psychology to gain system access, generative AI can play a vital role in reconnaissance. For example, an AI model trained on a large data set of phishing attempts and social engineering tactics could generate realistic potential phishing emails or scam messages. The ethical hackers can then use these samples to educate the organization's employees and develop effective preventive measures. Overall, the convergence of generative AI and ethical hacking is having a transformative effect in the field of cybersecurity. The role of AI in the optimization and enhancement of the reconnaissance phase significantly contributes to creating robust defenses against potential cyber threats. By embracing this symbiotic relationship between AI and ethical hacking, organizations can navigate the digital landscape with greater confidence and security. In this demo, I used generative AI to summarize information gathered using passive reconnaissance. All right, so imagine that I've done some passive reconnaissance using your typical open source intelligence tools like just searching the web, using a couple of different search engines, and so on. So we've returned this massive amount of reconnaissance information, and we want to use generative AI to summarize that information for us. Okay, well, I've done exactly that in a script named passive-recon.py. Let's explore passive-recon.py. So on lines 2 and 3, I import the modules that I need, OpenAI and the OS module. Then on line 6, I retrieve my OpenAI API key that I've configured in an environment variable named OpenAI_API_key. Starting on line 9 is the passive_recon_summary function definition. It's in this function where I make the call to the OpenAI.completion.create method. The passive recon summary function takes a single parameter, query, which represents the prompt passed to it in the call to the function later on in the Python script on line 32. We'll get to that in a moment. So on line 10, the OpenAI API call is made using, as mentioned, the OpenAI.completion.create method. This method creates a completion task, which generates text based on the provided parameters. On line 11, the engine parameter specifies the engine for the text generation. In this case, the engine is text-DaVinci 002. This engine is a variant of the GPT 3.5 model, and it's optimized for generating text. On line 12, the prompt parameter is where you provide the input text or prompt for the text generation. It's set to the value of the query string variable. On line 13, the max tokens parameter determines the maximum length of the generated text. In this case, it's set to 100 tokens. The end parameter specifies how many different completions to generate. Here it's set to 1, so only one response will be generated. On line 15, I set the stop parameter to none. And on line 16, the temperature parameter controls the randomness of the generated text. Recall that a higher value, like 0.8 or 0.9 for example, or 1, makes the output more random, while a lower value, for example 0.1, makes it more deterministic. Here it's set to 0.1, meaning the model's output will be more deterministic. And this simply means that it will closely follow what it perceives as the most probable next token based on the input. This often leads to more focused and coherent text, but may sacrifice some creativity in the process. Okay, then on line 18, after making the API call and receiving a response, this line extracts the generated text from the response object. The response.choices list contains the generated completions, and response.choices0.text gets the text of the first and only, in this case, choice. The extracted generated text is stripped of leading and trailing white space using the strip method. Then on line 19, it's returned as the output of the passive_recon_summary function. Now, on line 22, I set up the name of the organization I've gathered the recon information about. Then on line 23, I set up the recon info F string with the information I've gathered using traditional passive recon. Okay, not a huge amount of information, but it's good information nevertheless. Next, on line 31, I create the recon_query F string, which is effectively the prompt used in the call to the GPT model. Then, as mentioned, on line 32, I make the call to the passive_recon_summary function, and the recon_query string is passed in as an argument. Then on line 33, I just print the summary. Okay, so let's run the code. So down in terminal, I'll type Python passive-recon.py, and I'm using tab to autocomplete, and I'll press enter. All right, so that created a summary of the information using the OpenAI API. It tells me all about Unito Games and that it's a Boston-based company who it was founded by, the number of employees it has, $30 million in revenue in 2023, its top products and services, and so on. Now, if I clear the screen and then up arrow to run the same command again, I should see pretty close to the same output. And it is very close to the same output. And the reason for that, again, is the temperature setting. I have it set to 0.1, so the model's output will be more deterministic. All right, and so with that, we've used generative AI to summarize information gathered using passive reconnaissance. In this demo, we use generative AI to analyze information gathered using active reconnaissance. Okay, to get started in my demo, I've opened my browser and I've navigated to nmap.org/book/man.html. This is the Nmap reference guide. One of the ways that we can start with active reconnaissance is by performing a host discovery using a tool like Nmap, for example. Nmap is a very common tool for just such endeavors. We can use it to quickly find hosts, find any open ports, and then we can focus in on those ports and the services running on those hosts. We can use generative AI to help us analyze all the active reconnaissance information that we've gathered. So let's go down to the taskbar. I'll select the Visual Studio Code icon to bring up Visual Studio Code, where I have a Python script open named active-recon.py. This is a Python script that interacts with the OpenAI API to generate text using a GPT model. Let's examine this code. So lines 2 and 3 is where we import the modules we need. Then on line 6, I retrieve my OpenAI API key that I've configured in an environment variable named OpenAI_API_key. Then on line 9, this is the active recon analysis function definition. Notice that it takes a single parameter, query, which represents the prompt passed to it in the call to the function. And we'll see that later in the Python script on line 37. On line 10, the OpenAI API call is made using the OpenAI.completion.create method, which creates a completion task and generates text based on the provided parameters. And the parameters, they're set from lines 11 down through 16. In a previous demo titled Performing Passive Reconnaissance, I went through each parameter in detail. In this script, though, I want to focus on a couple of parameters. First, note on line 12, I've set the prompt to the query parameter. Then on line 16, I set the temperature parameter to 0.5. Now recall that the temperature parameter controls the randomness of the generated text. A higher value closer to 1 makes the output more random, while a lower value closer to 0 makes it more deterministic. Here, I've set it to 0.5, so it's somewhere in the middle. I want the GPT model to be somewhat focused, but I don't really want it to sacrifice much creativity. Okay, next, lines 18 and 19. This is where I configure my message and return it from the active recon analysis function. On line 22, I define a Python dictionary variable for my gathered intel from active reconnaissance. This kind of dictionary structure is commonly used for organizing various pieces of information, and this includes information about a target during cybersecurity reconnaissance. So I've included the website URL, the web technologies that I've noticed, open ports, and observed pages. On line 33, I engineer the prompt for this exercise, and notice that I specify to the GPT model that I want it to analyze the information and recommend any potential vulnerabilities. The nice thing about this is that if I want to change the prompt, if I want to engineer it differently, I just come here and I change my recon query. Okay, then on line 37, as mentioned, I make the call to the active recon analysis function, passing the recon_query argument. Then on line 38, I print the analysis. Okay, well, let's run this script. So down in terminal, I'll type Python active-recon.py using tab to autocomplete and press enter. And from the analysis, we're informed that the website is using outdated software versions which may contain known vulnerabilities, that the website is not using HTTPS, the website is using a number of open ports which may be exploited, and that it has a number of observed pages which may be targeted by attackers. Now I'll clear and then run the script again, and let's see if we get something a little bit different. And we do. It actually mentions the specific protocols and services that are running and that they may be exploited by an attacker. All right, well, with that, we've used generative AI to analyze information gathered using active reconnaissance. This video explores the potential challenges and solutions of generative AI applied to reconnaissance. Advancements in AI and machine learning have sparked a significant revolution in diverse sectors, and the field of ethical hacking is no exception. Generative AI has significantly changed reconnaissance in some significant ways. It offers different solutions to reconnaissance, but also carries some potential challenges. Let's explore both in detail, starting with the challenges. The use of generative AI in ethical hacking and reconnaissance comes with various challenges, primarily due to its ability to create new and unforeseen outputs. While its function is beneficial, it does pose potential threats in the reconnaissance phase. These are due to data privacy, unpredictability, and complexity issues. First, data privacy. The AI models used in reconnaissance have access to vast amounts of data. In the wrong hands, this information could be exploited to infringe on user privacy. The challenge is even more pronounced with generative AI, given its ability to extrapolate and generate information that may not have been publicly available. Then there's the challenge of unpredictability. The inherent nature of generative AI makes its actions somewhat unpredictable. This unpredictability can lead to unexpected results or potential false positives in the reconnaissance phase, which can have grave implications if not handled correctly. And complexity. The complexity of generative AI models makes it challenging to ascertain their decision-making processes. This lack of transparency can potentially pose a threat, especially when deployed in high-stakes environments. Let's consider a couple of realistic examples. Consider a scenario where an ethical hacking team uses a generative AI model for reconnaissance. The model is designed to scan a company's public-facing infrastructure and generate potential attack vectors. If the model extrapolates data about an employee that was not publicly available, it could lead to privacy concerns. In another example scenario, an ethical hacker using generative AI in reconnaissance might discover that the AI model has identified a seemingly vulnerable spot in the system. If the model erroneously flags this spot due to its unpredictability, it might lead the ethical hacker down a wrong path, wasting resources and time. Okay, so now the solutions. While the cited challenges are significant, generative AI also brings robust solutions to the reconnaissance phase. First, improved decision-making. By providing comprehensive information on potential security threats, generative AI can significantly enhance decision-making during the reconnaissance phase. This can help make ethical hacking more efficient by ensuring that resources are properly allocated in an optimal manner. Then there's efficiency. Generative AI can work 24/7 without fatigue, providing constant surveillance and identifying potential threats much faster than human counterparts. This greatly reduces the time spent in the reconnaissance phase and allows for a quicker resolution of vulnerabilities. Then there's adaptability. Generative AI can adapt to new security threats and vulnerabilities, keeping pace with the ever-evolving cyber threat landscape. This adaptability allows for more proactive and dynamic approaches to ethical hacking. Now, here are some notable benefits of leveraging generative AI in reconnaissance. Speed. Generative AI accelerates the process of identifying vulnerabilities, resulting in faster mitigation of risks. Efficiency. By automating the reconnaissance phase, more resources can be allocated to vulnerability exploitation and resolution. There's enhanced predictive capabilities. Generative AI can forecast potential security threats, allowing proactive measures to counteract these threats. And, as mentioned, round-the-clock operation. Generative AI provides constant surveillance, ensuring uninterrupted protection against cyber threats, and scalability. As AI can handle large volumes of data, it can easily scale its operations to monitor larger infrastructure. Overall, generative AI is undeniably a double-edged sword in the context of ethical hacking and reconnaissance. While it presents challenges like data privacy, unpredictability, and complexity, it offers valuable solutions and benefits. The key lies in establishing robust regulatory frameworks and ethical guidelines to harness its full potential while mitigating possible risks. the application of generative AI in ethical hacking is still in its infancy and will undoubtedly continue to evolve, bringing with it new challenges and opportunities. This video explores how to protect systems and networks from reconnaissance. Recall that reconnaissance is the initial phase of an attack, where the attacker gathers information about the target. There are steps that organizations can take to minimize the risk and safeguard systems and networks against reconnaissance. Let's consider these measures: robust access controls, network segmentation, intrusion detection and prevention systems, regular updates and patching, and educating and training users. By implementing these measures, organizations can significantly enhance their defenses against reconnaissance attempts, making it more challenging for attackers to gather crucial information and plan their subsequent attack steps. These measures, along with regularly reviewing and updating security strategies in response to emerging threats, is essential to maintaining a robust security posture. Let's explore these 5 measures to better understand them. Okay, so implementing robust access controls is crucial to protecting systems and networks from reconnaissance. Some ways to achieve this include enforcing strong password policies. This means complex passwords with an expiration, they must not be reused, and they should be securely stored with password management tools. Regularly review and update access permissions. This calls for regularly auditing user access, removing unnecessary privileges, limiting access to essential resources, and promptly revoking access during role changes or employee departures to prevent any unauthorized access. And then there's multi-factor authentication. Robust access controls includes enabling multi-factor authentication to add an extra layer of security by requiring additional verification factors, which has the added effect of reducing unauthorized access risk even if passwords are compromised. Employing network segmentation is an effective strategy to protect systems and networks from reconnaissance. This calls for segmenting the network into isolated zones based on functions, departments, and sensitivity levels to restrict attackers and limit breach impact. This means combining segmentation with the implementation of effective firewall rules. This entails enforcing strict firewall rules to control traffic between network segments, allowing necessary communication while blocking unauthorized access attempts. By employing network segmentation and implementing robust firewall rules, organizations can not only enhance their defense against reconnaissance activities, but it also effectively helps mitigate the potential impact of an attack. Then there's employing intrusion detection and prevention systems. Install sensors strategically throughout the network to monitor and analyze network traffic to detect suspicious activities and reconnaissance attempts. One should also configure real-time alerts. The intrusion detection and prevention system is configured to generate real-time alerts and notifications when it identifies potential reconnaissance activities. This helps ensure that there is an immediate response and subsequent mitigation against reconnaissance. And, of course, keep the intrusion detection and prevention system up to date with the latest threat intelligence by regularly updating signatures and rules. This ensures the system can identify new reconnaissance techniques and patterns effectively. By implementing sensors, configuring real-time alerts, and staying updated with signatures and rules, organizations can proactively detect and prevent reconnaissance activities, bolstering the overall security posture of their systems and networks. Now, you should probably understand that what we're talking about here are really best practice security measures. And this one is no different. Regularly updating and patching systems is a vital step for protecting systems and networks from reconnaissance. Here's why. Patching addresses known vulnerabilities exploited by attackers during a reconnaissance. Updates improve system security, fixing any identified weaknesses or bugs. And regular updates ensure systems have the latest defenses against emerging reconnaissance techniques, enhancing overall resilience and reducing the attack surface. And one final measure to consider, educating and training users. This is so important for protecting systems and networks from reconnaissance. This involves providing security awareness training. An educated user is a safe user. Educate users about the risks of sharing sensitive information and teach them to recognize and report suspicious activities. We want to ensure that phishing awareness is top of mind. So with that, train users to identify phishing emails, and avoid clicking on malicious links or providing sensitive information. We can ensure these measures are adopted by regularly reinforcing best practices. This can be achieved by conducting ongoing training sessions to reinforce security best practices and ensure users understand their role in protecting systems and networks from reconnaissance. This video explores how to use prompt engineering to enhance the effectiveness of reconnaissance techniques in ethical hacking. Effective prompt engineering enhances reconnaissance by guiding language models to generate targeted and relevant information. Crafted prompts allow researchers and analysts to extract valuable insights from language models like ChatGPT. By carefully designing prompts, reconnaissance efforts can be optimized to obtain desired and actionable results. In this video, we'll explore the components of prompt engineering, including understanding the objective, defining the context, generating focused prompts, refining prompts iteratively, and incorporating follow-up questions. Okay, so understanding the objective. This means understanding and defining the reconnaissance objective to ensure that prompt engineering aligns with the desired information or insights. To ensure relevant information is generated, it's crucial to thoroughly grasp the context of the reconnaissance task, including the industry, the organization type, geographical location, and potential adversaries. Then, to maximize the effectiveness of our reconnaissance efforts, we prioritize information needs based on their importance and relevance. By focusing on the critical details, we can quickly generate valuable insights. Next, define the context. So here we set the scenario. We must understand and define the reconnaissance objective to ensure prompt engineering aligns with the desired information or insights. We design prompts that focus on specific keywords related to the objective, directing the language model's generation towards relevant information. We provide background information and define the scope. The scope of the reconnaissance task should be clearly outlined in the initial prompt. It should specify any limitations, constraints, or specific areas of focus to ensure that the language model generates responses within the intended scope, avoiding irrelevant or extraneous information. Next, craft focused prompts. To craft focused prompts, we need to be specific. This means understanding and defining the reconnaissance objective to ensure prompt engineering aligns with the desired information or insights. We need to carefully craft the prompt so that it has domain relevance. This helps provide valuable insights for decision making. By being specific and emphasizing the domain relevance in the prompts, we can enhance the effectiveness of prompt engineering and guide the language model towards generating focused and valuable information for our reconnaissance objectives. Next, iterative prompt refinement. To refine prompts iteratively, we first evaluate generated output. Analyzing the language model's responses, assessing relevance, accuracy, and level of detail reveals areas of incomplete or incorrect information, aiding understanding of strengths and weaknesses for improvement. Then, we refine and optimize prompts based on evaluation to elicit accurate and comprehensive responses, aligning with reconnaissance objectives. By evaluating the generated output and making iterative adjustments to the prompts, we can improve the effectiveness and relevance of the generated information. The iterative prompt refinement process ensures that the language model produces more accurate and valuable insights over time. And finally, incorporating follow-up questions. To enhance reconnaissance techniques, we can request concrete examples or evidence to verify the accuracy and depth of initial responses. We can uncover hidden information by seeking clarification or more specific details, revealing gaps and achieving a comprehensive understanding. And we should always encourage alternative perspectives, as this provides a balanced analysis with a broader picture, enhancing prompt engineering for gathering diverse information. This video explores how to use the information gathered during the reconnaissance phase in ethical hacking. In the reconnaissance phase of ethical hacking, the goal is to gather as much information as possible and use that information throughout the remainder of the ethical hacking lifecycle to strategize and plan testing efforts. Gathering information is one thing, but there are several key steps that should be followed in order to effectively apply the information gathered during reconnaissance. These include organizing and analyzing data, assessing the strengths and weaknesses discovered, developing a strategy and plan, sharing information with relevant parties, and maintaining operational security. Let's explore these in some detail. Okay, first, organizing and analyzing data. This involves identifying patterns, trends, or correlations within the collected data. There may be recurring themes, commonalities, or anomalies that may provide valuable insights. This analysis can help us understand the target's behavior, vulnerabilities, or potential areas of exploitation. We evaluate the significance of the information. We assess its importance and reliability and prioritize information that's verified, consistent, and relevant with the objectives. This evaluation helps us focus on the most critical information and avoid basing decisions on unreliable or possibly misleading data. Assess strengths and weaknesses of the organization's security posture. This includes resources. Reconnaissance helps identify the resources available to the target. This includes financial assets, technological capabilities, skilled personnel, infrastructure, and alliances. Next, we'll assess security measures. Security measures and protocols like physical security, network security, encryption methods, access controls, and incident response capabilities are assessed, and this will determine whether this is a strength or weakness. Knowledge possessed by the target, like qualifications, certifications, and experience of key personnel, as well as the organization's reputation and track record, are also assessed. Knowing the resources, security measures, and expertise of the target allows for a better understanding of their capacity to defend against attacks or execute strategies effectively. As part of our assessment, we'll explore vulnerabilities, such as software vulnerabilities, misconfigurations, outdated technology, weak passwords, or inadequate employee training. Exploiting these weaknesses can provide an entry point for attacks or compromise the target's security. We look for operational gaps. This includes inadequate backup and recovery strategies, lack of disaster preparedness, ineffective incident response plans, or poor employee awareness. And another weakness could be external dependencies, such as third-party vendors, supply chains, or service providers. These dependencies introduce potential vulnerabilities, as weaknesses in these external entities can indirectly impact a target's security. Assessing the resilience and security practices of these dependencies is crucial to understanding potential weak points. Okay, next, we strategize and plan using the information gathered during reconnaissance. Vulnerability remediation includes identifying and prioritizing vulnerabilities. It's vital to not only patch vulnerable systems, but it's equally important to implement security best practices like robust access controls, enforced password policies, two-factor authentication, and regularly reviewing and updating security configurations. As part of the strategy and plan, security awareness and training is paramount in order to educate employees about social engineering risks by conducting simulated phishing exercises that promotes a security-conscious culture. And incident response planning helps to establish roles and responsibilities like designating incident response coordinators, technical experts, communication liaisons, and external contacts. This information can be used to conduct regular exercises or simulated incidents to test the plan's effectiveness. Another important step is to share the information. This includes sharing to relevant internal teams. This is the basis for collaboration and coordination of organization-wide security practices. Then there's stakeholder communication. This is communication provided to executive management, employees, and customers or users. And then there's external sharing. This means sharing the information with trusted partners or vendors. Relevant information here includes legal and contractual considerations that may come into question based on information gathered during reconnaissance. And finally, maintaining operational security. Access control and privilege management includes user access reviews using strong authentication and password and account management. Network security includes segmentation and network zoning, firewall and intrusion detection prevention systems, and encryption using best practice secure protocols. And finally, incident response and monitoring includes security monitoring through incident response planning that creates employee awareness. So in this course, we've examined the interplay between generative AI and cybersecurity. We did this by exploring reconnaissance and prompt engineering techniques, reconnaissance methods and tools, and benefits of reconnaissance. We explored passive and active reconnaissance, challenges and solutions protecting against reconnaissance. We also explored applying prompt engineering for reconnaissance effectiveness and applying information gathered during the reconnaissance phase. In our next course, we'll move on to explore how generative AI and prompt engineering are utilized in the scanning and enumeration phase of the ethical hacking process.